Paul Luther is a registered professional engineer who has opened a consulting service following a 32-year career with Purina Mills in St. Louis, Missouri. During that time, he served as manager of environmental and safety services, director of regulatory quality, and environmental health and safety. Under the alliance between Purina and Land O'Lakes, he managed the environmental health and safety program for the feed division. He is also a former chair of NGFA's Safety, Health, and Environmental Quality Committee. Paul has a lengthy list of recognitions, topped by Purina's Danforth Award and being named Member of the Year for the American Feed Industry Association. He holds a Bachelor of Science degree from DePaul University and a master's degree in environmental engineering from Clemson. Following his retirement from Purina in 2012, Paul established a consulting service for environmental health and safety. He provides training on dust explosion prevention, confined space entry, lockout tagout, OSHA citations, environmental compliance reviews, permitting applications, and air emissions inventories. Let's please welcome Paul Luther.
Thank you, Jess. I do appreciate the coveted time slot immediately following lunch. You know, it's only topped by that highly coveted slot pre-beer. So at least I got the number 2 slot today. Thank you. Grain elevators have been around for, back to the 19th century. These earlier ones, like the ones you see on the left, were very, very simple. They were basic structures. They had storage bins, an unloading system, and a scale of some sort. Any safety considerations that were designed into these elevators were probably due to stories from the elevator down the road in the next county where Joe got his hand mangled because he got it in the wrong place. So safety was obviously not top on the concerns. These basic structures were pretty much wooden and became obsolete due to their limited storage and due to the construction materials and the newer materials that we had to build them, such as the one on the right. And even with the ones on the right, how much safety forethought was put into these. Keep in mind that the Occupational Safety and Health Act did not get passed by the 91st Congress until December of 1970, so certainly anything that was designed and built prior to that, there was no OSHA regulations to be concerned about. And then the grain handling standards, that little Bible that I found out today was not, according to the CSB, was not promulgated to help with grain explosions, but for some other reason. I didn't know that. It took me 33 years to figure that out, Jess, but I appreciate that. But those didn't come into effect until 1987. So what are we doing today? We're building bigger, faster facilities, where before we were talking about 5,000, 10,000 bushels per hour. We're looking at 20,000 and up bushels per hour for receiving. Drag belts, conveyors are bigger and faster. With the throughput that goes through this equipment, majority of the changes have occurred in the past few years have been safety related. And I was very pleased to hear Bill talk about it in the session before lunch, that safety now has a seat on the engineering and the feasibility designs, and that's where it needs to be. It's become an integral part of any project. With my career with Purina, in the last half of my career, let me say that I was involved with 9 major constructing of 9 facilities and or retrofitting of 9 facilities. I was fortunate enough to be on the initial committees, on the engineering committees, on the feasibility committees. I got a seat at the table initially. What I tried to do in that position was to, in effect, do a job hazard analysis, looking for the hazards before we built the thing so that we could perhaps engineer those things out. Your first level of hazard prevention is to engineer the problem out. Your second level is to provide administrative controls, and third, you get PPE, personal protective equipment, to address any hazards. So the first level is what we were concerned about. The items that I'm going to present here today, I'm going to give you about 12 little examples of issues that became important to me through this process of 9 facility reviews. Took time to look at these things. Got better as we went along. I look back at what we did or didn't do during the first couple. We made some mistakes. We learned from them. The one common thread, though, that I realize for all the items we're going to talk about is they cost money. And obviously, you know, you have to consider whether or not you want to spend the money now, you want to retrofit later. What's this do as far as the safety of our facility regarding potential comp claims? You know, that whole cost discussion needs to be involved. What I'm not going to do is focus on structural or civil engineering. You've got some vendors out there that can help you with these issues. It's very important, though, as you know, that we've had way too many structures collapse in the past. Concrete elevator in Russell, Kansas in June of 2010, and just last month, the metal facility in North Carolina. I think and definitely on the one in Russell, Kansas, there were some fatalities involved. So we certainly a very important part of the building structures. And you've got a lot of construction resources out there, NFPA 61, and according to Mr. Norris this morning, you're going to have 652 pretty soon to rely to. National Electric Code, insurance companies, American Con. There's a lot of resources out there for your structural situations. Okay. I'm going to go through about 12 items, as I said, and you're going to know when I change topics because it's going to be in red, it's going to be numbered at the top. But the biggest item that I found, the biggest fallacy in the initial designs is providing work platforms for people where they need them. You know, all new facilities and machines will be equipped with OSHA-compliant work platforms and guards. But do you have enough, and are they where you need them? And as Bill said in this morning, you need to be having your operators and your maintenance crew involved in this initial conversations. Where do you guys need to get to? How do you need to get there? You know, ask them. If you don't ask them, you're going to miss it. Here we have a nice new construction. You got guardrails that are compliant. You've got mesh. You got toe boards, and you don't have any openings there where you can trip and fall. You got good machine guards. You got a staircase going up to the upper level. Again, you got a nice platform there, work platforms that are conducive to having your operators and your maintenance crew do their job effectively. I'm not going to pick on this piece of equipment necessarily, but I'm just going to just point out a few areas where I would get involved and say, okay, do we need access? You know, over here on the left, you have this spreader, this valve for the spreading on this cleaner. Obviously, if you install something, it's going to need to be maintained. So how am I going to access that? You see the guardrail, that's 42 inches tall, so that valve up there, that's probably a good 6-7 foot above ground. How am I going to access that? Is a ladder going to be sufficient? These machine guards here on the right, again, they're above the guardrail, but I can probably get to them safely. You know, down below, I've got some hoppers here, I've got some spouting. How often am I going to have to get to that? How high off the ground is that? How can my people safely get to those locations? So work platforms is the key. Put them up where you think you're going to need them, and then keep monitoring that situation. Every piece of equipment needs to be maintained. I know one of the points that Bill was mentioning this morning is maintainability, maintainability, maintainability. You got to be able to get to your equipment. So consider access to the equipment you're installing. Could be platforms, catwalks, or simple tie-off points, and we'll get to those in a little bit. How wide is wide enough for a work platform? Okay, you think you may need a work platform, but how wide is wide enough? Well, OSHA doesn't come out and tell you it needs to be X, Y, Z, but there's 4 various mentions in the OSHA regulations on work access. The first is an exit access must be at least 28 inches wide at all times. So there's your first point. 28 inches may be what you want. Where doors or gates open directly on a stairway, platform shall be provided and the swing of the door shall not reduce the effective width to 20 inches. So there's another mention of work platform space. Landing platforms are for ladders. When you have over a 30-foot ladder, you need to have a landing platform. They're not to be 24 to 30 inches. So, you know, if I'm looking at, and then for electrical standards, if you're looking at a work platform around some electrical equipment, the new standards require 36 inches minimum clearance, 42 inches for 40 volts or higher. So, you know, pick your poison, if you will, but the key is you don't want to have a knuckle banger. You want to have enough space on that work platform that your operators can adequately address their equipment there. You know, when I'm going a minimum of 28 inches, and I'm going wider if possible. Think about installing stairs rather than ladders. How much stuff can you carry up a ladder? None. You're supposed to have 3 points of contact at all time. So unless you're carrying a tool belt, you're not going to be carrying anything up a ladder. Stairs, you can carry a lot up a stairs. Yeah, they cost money. But just think about how much easier it's going to make the job of getting to that greasing zerd up there 200 feet if he's got a staircase to climb up instead of a ladder. Stairs into boot pits is another example. Not only is it going to help your operators and your maintenance crew keep this area clean, they can carry, spilled grain up and down that staircase, but also the added benefit that Jess mentioned this morning, maybe, just maybe you have a conversation now on taking this particular boot pit out of the confined space conversation. At least you can have that conversation if you have a staircase in there. Swing gates are best on work platforms, yeah. You can use chains, but how many of you have ever seen a chain not stretch back across to on that access point? You see them all the time. Build steps over conveyors to avoid stepping onto the lids, and don't use the equipment as platform. Here's a swing gate. You got a work platform. What you don't want to do is have your workers in a position where they're working, not paying attention to where they are, and they could back off of that platform. That's why you need some protection up there. Swing gates I found are best, but like I said, if you have chains, they can be used also, but chains don't get rehung all the time. You got to get from point A to point B, and you got a conveyor that's at about a 4-foot height. You want to go over, you want to go under, or do you want to go over a step ladder? This little platform here is removable, is movable and removable because, yeah, you got to take that lid off, and yeah, you got to get into that conveyor every now and then. But again, having this little step ladder is going to save that operator of yours, that maintenance crew, from having to sneak under there, probably banging his head on that conveyor several hundred times, or trying to go over the top of it. Are conveyors a good stepping point, a good work platform? No, they're not. The conveyor, when you install it, is going to have a nice solid lid, and you can sit on there and bounce on it a couple of times. It's not going to deflect, but the stuff we put through these things called grain is pretty corrosive. And over time, what's going to happen? It's going to rust, it's going to get thinner, and maybe 10 years down the road, you're going to have some deflection in there. So that operator who has been having the habit of standing on that platform, that conveyor, and step over, someday he may get surprised and that thing cave into him. So make some access for him. Alternatives, okay, work platforms are nice, they cost money. If I got to get someplace once a year, do I really want to put the expense of a work platform up? Maybe, maybe not. Some alternatives that are available out there, the D-rings are on the left. You've got a 5/8-inch stud with an expansion anchor that's ideal for applications with concrete. Those can be either horizontal or vertical, and I've installed quite a few of those over my career. The next one on the right there is a wire hook that you just squeeze in the middle, and if you've got a sufficient anchor point, you hook it on there, and it can withstand about 400 pounds of force downward. And then the adjustable beam used in the construction industry. You can put it on an I-beam, an H-beam, horizontal, vertical, 3 inches to 24 inches. Again, a nice temporary tie-off point. Once you have your project done, built, completed, like I said, you're not going to catch all these areas that you need to have work platforms or fall protection. So certainly after the first year, after you're up and running, go out there and do a fall protection review, if you will. Talk to your operators, talk to your maintenance people. Where have you been going that I need to know about? And is there some place you would want to go? As I got a little older in my career, my level of handling risk diminished, and no, I don't want to go up that anymore. I want a nice ladder to go up or a nice stair to go up. And look for signs where work access is needed. Just a couple of good examples here. I got a hopper up here, and I got a hammer and some marks, and I got footprints down below. Pretty good indication that somebody's going up there, and that's well above the 4-foot level that you need to have some fall protection. So what are you going to do there? You're going to put a platform up. You want to put a temporary hook on there or whatever. Just again, you built your facility. Now go out a year later and look at it. Again, footprints on a fan. What's he doing up there? Where is he trying to go? Maybe a simple ladder is going to be sufficient for that, but something is needed to address that situation. How do I get to the other side of the motor? Okay, I'm going to have to slide over that conveyor. On the right here, ladder used to access a patch. Well, Hopefully that's not going to be something you do every year, every 10 years. So maybe in this particular case is a temporary tie-off that you're going to use. Again, this is your annual fall protection review once your facility is constructed. And this is my lumber storage area, right? This is where I store my lumber. Obviously somebody's using that, this is a very old photo obviously, but somebody is using that plank to access that motor. Not a good situation. So these are the types of things you want to look for after you've built your facility, picking up those pieces that you missed. Topic number 2, truck rail unloading. First of all, do you need it? Jess addressed it today, this morning, where that stands, the Miles memo, the issues that are out there. So your first consideration is, do you need it? And if you don't necessarily need it, do you want it anyway? I've been involved with, unfortunately, in my career, there were 2 fatalities of contract haulers that fell off of their trucks, and you know, obviously they were fatal situations. You know, right there, do you want it? That's your answer right there. Then the next question is, how much fall protection on the rail do you need? The one mistake I made was not putting enough of it up. This is a system that we retrofitted in after this facility was built, and we didn't put enough in. We found out that we put, I don't know what it was, 6 car lengths we put in there, and they needed about twice that. Because what they had to do was go in there, sample the first 6, get the rail car mover, move those out, and pull the other 6 in. At least that's what they said they were doing. What was happening on the 3rd shift when nobody was around? Didn't want to ask those questions. But are they using the fall protection that's out there, or do we need to put more out there to address those situations? A lot of good fall protections. We built the one on the left. It's a rail situation. Staircase on the outside. You walk up through the door, comes down. You've got tie-offs for 2 people. Grain probes for trucks. I love them. We put a lot of those in the past 10 years. There's a couple vendors here for grain probes. Again, that eliminates the guy getting on the truck, walking around, and potentially falling off the truck. And or on the bottom photo there, you've got a nice long platform that you can observe the truck, the grain coming in the truck. You can take samples, whatever you need. Some of these things are not all that expensive either. Here's another one, another truck platform. Again, the door on the left, you walk up an outside slather. The one on the right here is both a combination truck and rail. It's truck on the left, rail on the right, one platform. It services both. Again, I got a staircase going up. Makes the job a lot easier for your operators. Number 3, machine guards. Is that you, Jess, in that picture? That looks a little bit like you. I don't know. Okay. Machine guarding is required on parts which are 7 feet or less from a floor or working platform. I'm 6 foot tall. That's 7.5 feet right there. That 7-foot standard dates back to 1950. Now, I wasn't even around in 1950. I imagine 1 or 2 of you are, but that is a real old standard. My recommendation is just go right past that 7 foot and go to 8 foot, 9 foot. One of the reasons you're putting machine guards up is to prevent unintentional contact through trips and falls. So if I'm walking along and I'm pretty clumsy with my shoes and I trip on something and I see something's up there at the corner of my eye, I'm going to grab for it. And if that machine is not guarded at 7 foot, and I'm 7.5 foot, I'm going to grab a hold of that pulley right there, and I'm going to have a little problem there. So go for 8 foot at least, if not more. I mean, the machine guards are not all that expensive, but the 1950 ANSI standard is pretty outdated. Also, don't assume that all new machines that you put in are OSHA compliant regarding machine guards. Here's a fairly new conveyor we put in, a screw conveyor. And look at that shaft. OSHA's rule says projecting shaft ends shall present a smooth edge and shall not project more than 1/2 the diameter of the shaft unless guarded. That thing's a lot more than 1/2 the diameter of the shaft, and it's not guarded. So we bought a new screw conveyor. We had it engineered, put in. It is not OSHA compliant. Pretty simple to make that OSHA compliant. You either put a guard around it or you cut the shaft off. But again, you don't assume that when you buy something brand new off the shelf, it's going to be OSHA compliant. And here's one. What's wrong with this guard? I can get my hand in there pretty easily, can't I? You know, this is one, again, this is about 2 years after the facility was up and running. Went back and found some situations like this and said, wow, we kind of missed on this one. Machine guard spec wasn't quite as tight as it should have been. You've got to have 4 sides guarded, and obviously that's just not going to cut it. I can easily get my hand in there if I wanted to. Lockout, tagout considerations. Strongly consider local disconnects when you're building your new facility, designing your new facility, that in areas that are not directly accessible to your motor control center. It's much easier for your operator to lock out a piece of equipment if it's within reasonable access of that piece of equipment. If I got to go from the bin deck, catch the man lift or the elevator, go down to, and if the elevator's probably stuck on the third floor because somebody's got the door open. If I got to wait for that elevator, go down to the basement, go into the MCC, flick that breaker, put my lock on, and then go back up, the odds of that occurring 100% of the time are maybe not perfect. But if I've got a local disconnect handy, it's going to happen a lot more often. It's going to happen hopefully 100% of the time. And I'm going to talk about trapped keys in a second and limit switches here. New bin, put a sweep auger in, and if this morning you saw the list of the 10 commandments of the sweep augers, points of light, 10 points of light. One of them was to lock out your sweep auger when somebody goes in. Okay, I've got my disconnect right there at the door. It's going to happen. It's going to happen a lot more than if I have to go into the building, down the floors, into the motor control center, and back out, doing that 15 times in a shift. Right there. Trapped keys. Trapped keys have been around for maybe 15 years, and the essence is you got one key, and if it's in the box, you go, and if it's in the door, you're not going. That does disconnect the power to the motor. The OSHA lockout tagout standard was developed somewhere, I think around 76 or something, prior to trap keys being put into use. Back in 2004, everybody's putting these in machines and in all the various types of industries, along with the ANSI, American National Safety Institute, and the American Society of Professionals. We petitioned OSHA for them to, quote, accept trap keys, and after several layers of negotiation and letters, they basically said, yes, we recognize this as a valid method of locking out a piece of equipment. However, since it doesn't meet the classical definition of tag and lock and tag, you're okay unless somebody gets hurt, is what they basically said. So, they were covering themselves, but in all the years I've had trap keys out there, I've never seen anybody get hurt with one of these things. Interlocks. Interlocks can be beneficial to you, but you certainly got to know where they are, and you have to train your people on how to use them. Again, when you're installing a new piece of equipment, designing a facility, where are these applicable? You'll see this conveyor here has a hinge on it, which means that it needs to be, is used as an observation point quite routinely. Without this limit switch on there, the obvious temptation is simply to lift that hinged piece of the conveyor top up and take a look at what you're doing. No, I'm not going to stick my hand. I'm just going to look. That's all I'm just going to look. Well, that's pretty good temptation when you've got that open to, pick out that piece of grain, that piece of plastic that's in there. So this is where your limit switches could come into play. They're interlock guards, and if you put these on, you certainly want to make them so that replacing the guards does not automatically restart the machine, because if they do, you're just going to put your thumb on that thing, and away she goes. Also, I noted here that you need seat clamps to secure these lids. I've been seeing citations where OSHA says you have loose-fitting lids, even though if they've got a lip on them and the top extends down. Basically, OSHA's looking for clamps or screws on these things. Why consider electrical safety? You got a discussion tomorrow, sessions coming up tomorrow on electrical, and there'll be a lot more in-depth discussion, I assume, during that presentation. But why do you want to consider electrical safety in your designs? The accident triangle right there tells you why. Overall safety, slips, trips, falls, everything. 300 recordable injuries is one fatality out of that. With electrical, for every 10 recordable injuries, you've got one fatality. So the stakes are a lot higher. You should know these definitions already. Class 2, G1, D1, dust under normal operation sufficient to produce explosions. And Class 2, G2, dust under normal operation, not sufficient to produce explosions. There's more to those definitions, but that's for guys like me who just want to simplify it. Make sure your electrical contractors know this. Don't assume that they know which areas of your facility should be 2G1, 2G2. You make that assumption, you may end up paying for it later. And again, why is this important? This was out of the newspaper article, June 26, 2013. A motor malfunction in ignited grain in Union Mills, Indiana, causing a fatal explosion. Down at the bottom, it appears those motors were overheating and very possibly had been the source of ignition for the grain dust. I don't know anything more than that. I don't know if they were properly rated or not, but this certainly shows you why you need to nail this up during your design phase. MCCs, NFPA 70E, arc flash hazard labels. All your new motor control centers need to be in designated rooms. I've seen way too many of them that were built in the last 2 decades that were at the side of a warehouse or near in the break room or whatever. They need to be designated rooms with 2 exits. All your boxes need to be labeled with the identification as to what they shut off, the voltage, and a hazard label. Now the hazard label, the NFPA hazard label is over here on the right, and it shows you all of the pertinent issues there that you need, including the approach boundaries, flash protection boundaries, arc flash incident energy, and required level of PPE. Again, that's an NFPA required label, not an NFPA suggested label. Currently, OSHA, what OSHA says, I shouldn't say all OSHA says, is in 1910-335, they say that safety signs, safety symbols, or accident prevention tags shall be used where necessary to warn employees about electrical hazards which may endanger them. So that's as far as OSHA goes today. This label certainly takes care of all that, but this label, as it's shown here, is not necessarily an OSHA requirement. However, when you're putting in new electrical equipment, putting any new equipment in, get this done. I mean, I don't know when it's going to happen, but later or sooner, arc flash hazard analysis are going to be required out there, and they're costly if you wait and do them after the fact. You're talking $10,000 to $40,000 to do an arc flash hazard assessment by a qualified electrical contractor. It depends on the size of your facilities and whether or not you have one-line diagrams. So when you're installing new equipment, I highly recommend you get that done up front. They should do it for you at cost almost. It's much easier for them to analyze this and to tell you what the hazards are than it is to do it later. And the advantage of doing an arc flash hazard analysis is it's going to tell you what PPE you need and how to mitigate some of your hazards. Potentially by just putting in a different size breaker or putting in some overcurrent protection, you can reduce the amount of personal protective equipment you need to be working on this equipment there. We did 3 or 4 arc flash hazard assessments, and in every one of them, with just some minor tweaks to our electrical panels, we were able to reduce the required PPE from a smock to something like the flame retardant clothing that Jeff was talking about earlier today. Positive ventilation, clean, not a storage area. I've probably seen, I can count the number of clean MCCs that didn't have cardboard storages in them probably on one hand. Everybody's going to put their fuses in there, their breakers in there, the spare parts for your MCC are going to be stored in there, and you're going to put them in your cardboard boxes. You don't want to do that. If you want to store the equipment there, just take them out of the cardboard boxes. And obviously, reset buttons external on all the buckets. You don't want to have to go in. The days of having to go in to push the reset buttons, those should be long gone. Finger-safe terminal blocks, somewhat new. They're used primarily in control panels, although they are rated up to 600 volts, so I think there's a little bit of use in these in more of the industrial situations. These will minimize electrical shock, obviously, but they're not going to do anything with the arc hazard, flash hazards. So you still may need, if you're working around these in the high voltage areas particularly, you still may need PPE to troubleshoot some light circuits. Switching to topic number 6, magnets. OSHA's GHS, and that is not the global harmonization standard. I'm old school. That's grain handling standards. We got to figure this out. We got to get these changed. Only requires magnets ahead of grain processing equipment with a little bit of asterisk there. The asterisk says that if you are receiving some large commodities such as corn cobs, as the example OSHA uses, then yeah, you're going to take that 2.5-inch grade out, and then they highly recommend magnets on your receiving systems. So right now, OSHA is only requiring magnets on grain processing, head of grain processing equipment. In the preamble, they say the 2.5-inch receiving grade is sufficient enough to remove all the tramp metal. However, magnets, obviously, as you know, will remove ignition sources, and I got some pictures here in a second, on your receiving legs. And the number one source of ignitions is that head pulley in your receiving leg. So pretty important to put those magnets up, in my opinion. Put a new magnet, a better magnet on a small leg, a small 2,000 bushel per hour leg. Did a day's study, and this is the stuff that we picked up. This is the big stuff that came off of that magnet. Every one of these is an ignition source. Every one of these is an ignition source that didn't get to the head house. And the small stuff, paper clips, a little metal rod in there that got beaten up. But this is why I'm a believer in magnets. Install magnets where you can get to them. We put in 20, 30 magnets here in the last few years that I was with Purina. And guess who forgot about work platforms? Where to put them? Yeah, kind of got ahead of myself. We put them where you couldn't get to them. You had to put a ladder up, you had to stand on a piece of equipment, and you had to use two hands to take them apart. So you basically had one point of contact on the ladder. You need 3 points of contact on the ladder. So in this particular case, the answer was putting those D hooks up, putting some sort of tie-off points up. Yeah, you're going to put your harness on when you go up there and clean that magnet off. Magnets should have labels on them. These things are strong magnets. Had one maintenance supervisor had the mistake of trying to take the bands off with a crowbar, and he just about got his fingers smashed on that little episode there. So magnets need to be labeled. Pacemakers, you know all the issues with magnets there. They should be pre-labeled. If they're not, when you get them, make sure those are on there. Leg monitors. They've improved quite a bit. I'm not sure how old leg monitoring sciences are, but I know back in the early days we'd put some on in Texas, and in summer in August it got up to 110 degrees and those monitors were going off all the time. So what did you do? You turned them off. Heck, they're going off all the time. No, it's just the weather. They've improved quite a bit, and particularly with these last two functions here that users can view the data now from any web-enabled device such as a smartphone, iPad, PC. You can see what's going on in real time. You don't have to send you don't have to rely on these control panels going off. You can see what's going on and have buzzes and emails sent to you. You also have PM alarms and emails sent to maintenance that you can use for predictive maintenance situations there. So they've come a long way. Here's just a fairly new system we put in a few years back with the rub blocks, temperature control, motion detector, all compact, all nicely there. New and old monitors, vibration sensing. Why would I want to put vibration sensing on a motor? Well, again, you're going to get this real time now. It's going to go to a PC, and you're going to find out if that motor's starting to shake a little more than it was a week ago. Again, get ahead of the curve here. Put this in on the startup of your facility, get some baseline data, and when you see that thing starting to move a little bit, go out there and take care of it. Spark detection, we did a little bit with spark detection, again, before I left the company there a few years back. We're having a little bit of trouble with the sensors getting clogged over by the dust, but again, I think they've come a long way in the past 2 years, and spark detection is in the future, and I think it was in the 652 review there that was talked about by Bill this morning. We all know about temperature cables. I've added one bullet point to the end of this that temperature cables, potentially you can use those to reduce the need for confined space entry. If you see a conditions that is approaching with the temperatures that is going to end up with some grain hanging up, hopefully you're going to take care of that for your quality, your aeration efficiency, but potentially it's going to help you reduce your need for confined space entry. Speaking of confined space entry, what is a confined space? Jess went over this a little bit this morning, but OSHA says you have to have 3 considerations. It has a size and shape that allows a person to enter and work, and has a limited or restricted opening for entry and exit, and is not designed for continuous human occupancy. So all 3 of those have to be lined up for the space to be considered a confined space. Then if it is, you have to find out whether or not you need a permit, or whether or not you can write a procedure which basically takes it out of the permit requirement. So when you're looking at a new facility, designing, taking considerations that can these spaces be designed so that they don't meet the definition of confined space. Again, the ladder that we had going down, the staircase that we had going down to the boot pit. Does that take it out of the definition? You got a conversation. And think ahead on ventilation. One of the items that you go through for permit required confined space is atmospheric hazards. If you've got a ventilation system in place that you build in, that you can rely on that 100% of the time, that hazard goes away, and maybe that is the one item that requires you to have a permit required confined space. So think ahead on that. Install ground level access doors. Much easier to get in from the ground than it is to climb up a 6-foot ladder and go into a 2-foot by 2-foot hole there. Install ankle, go into these in a second here. Here's two situations. You've got on the left, you've got a nice, fairly wide door. I don't think it's quite 6 foot tall to go through without ducking, but you certainly can get into that door a lot easier than you can the one on the right, where you've got to climb up a 6-7 foot ladder and then go squeeze yourself into a 2-foot by 2-foot hole, and then who knows what you're going to do on the other side of that. So you're designing your systems, you're designing your new tanks. Think ahead on your access doors. And by all means, put your in-bin restraint systems in, put those anchor points in, put your guide wires in. I know Wayne Bauer has done a good job, a good advocate for the industry in getting the silo manufacturers to install these. They need to be in there. Do it ahead of time. Do it up front. Do it now. Another option that's out there are the cone bottom unloading systems. These have applicability for tanks up to 44 feet diameter, 30 to 60 degree slopes. They don't work on everything, but we have used those successfully on corn. They rotate around and pull your ingredients down. Soybean meal and a few other things like that. They are quite effective. I've seen bins that were continually hung up. You install one of these things. Again, they're not cheap. No problems whatsoever from there on after. And Jess, I've got the answer for combustible dust. You've been waiting for it, haven't you? Use adequate dust collectors. If you're putting up a dust collector, make sure it's going to be 99% plus efficient at 10 microns. Do not, if you can avoid it, do not route that clean air back into your facility for several reasons. One, there's 1% of that dust coming back, and two, if you do have an explosion in that dust filter, and they do happen in those dust filters, you're asking for that stuff to come right back in. Another spot filters that return dust directly to the bin or the vessel. No ductwork is involved. NFPA 61 does recognize these. If you know the OSHA requirements being outside, deflagration, et cetera, these, if you will, are exempted. They do have air, but they basically just drop your dust right back into the vessel. They're good. Typically, they don't need air permits. Something to think about if you've got a dusty condition or you've got an area where your grain's not flowing as well as you want to, and you just need a little air assist there. Another one, spend a lot of time cleaning. There you go. That's a good answer, isn't it? Vacuum systems, if you put them in, Class 2, Group GD1, I put 3 in the past decade. They're okay. None of them were the complete answer. You just couldn't get to all the areas you needed to, but in my mind, they were better than not having them up at all. Include your pipe galleries, get to all these areas. Your pipe galleries, beams, ducts, and other high areas is where you really need to be able to get to with these areas. Just sweeping up the floor is nice, but that's really not what you want a vacuum system for. Design surfaces so they don't collect dust. Shrouds on covered beams. That's the I-beams, the H-beams are where you're going to collect dust. Put a shroud on them. It's going to help you a little bit. And fourth, design equipment so it does not generate dust and keep it maintained. I wrote down 700 bolts. One of these facilities that I went to that when we were designing, this isn't it, but it's a different one, went back about a year later and found out that the contractor basically had, for whatever reason, shorted us 700 bolts in the conveyors, the turn heads, the distributors, everything else. Missing bolts means dust. So if you're short 700 bolts, you need to have all those bolts in there. So keep it tight. You see in this little turn head here, there's one missing on the bottom, one loose on the top. Make sure your maintenance crew understands that those need to be tight to control that dust. Why explosion panels? Obviously, those explosion panels are much better for that panel to go than the entire bag house up there. Explosion suppression systems, a couple new options that we've been putting in. This one on the left is a quench venting system, kind of like it. What it has is a built-in quench system, and it has a stainless steel mesh in it. So basically, the idea is that the dust deflagration it mitigates the effect of dust deflagration by allowing the hot gases and burning material to safely escape the vessel being protected. Unlike explosion vents that simply vent to the atmosphere, this quenching chamber traps the dust emitted from the deflagration, absorbs the heat from the flame and burning gases. So again, there's some new technology out there. It's low maintenance. Installed a few of them. Haven't needed them yet, but pretty easy to maintain. On your right is your typical chemical suppression system that relies on a pressure differential. Again, back 20, 30 years ago, you put these in. They went off about every Friday. And finally, you just said, heck with this. I'm not going to resupply this chemical suppression. And you just, again, they've improved immensely. Lake venting, we had a good discussion before lunch on lake venting. I'm not going over that anymore. And it's some good discussions on Chapter 5 in NFPA 61. Two more items here to cover. First, contractor selection. Okay, you've got your safety people involved, your maintenance involved, your operations have all been involved in designing your facility, helping you design it, but let's make sure you've got a contractor that you're comfortable with, a contractor that works safely. Consider using a safety rating process to surface their problems before they become your problems. Key requirements might be take a look at your contractor's 300, your OSHA logs for the past 2 or 3 years. How many injuries does he have? Any red flags raised there? What kind of training is he providing his employees? Not only safety training, but on-the-job training for welding, for pipe fitting, et cetera. For large jobs, you certainly want to have one full-time safety representative contractor on place, and submit a specific safety plan for your project if you think that's valuable. Ensure your contractor knows your safety rules. Specifically lockout, tagout. Okay, you're putting in new equipment. Whose lockout program are you going to use, yours or his? Are you going to use yours, or are you going to have two programs? You're going to put locks on, but make sure you've got that covered. Also, hot work. I don't know how many times I've seen bin fires caused by contractors doing hot work. Just made aware of one last month. Contractor was up, some slag fell in the bin. Luckily, the procedure was there. It was caught. There was no issues. But make sure you're on top of the hot work during construction. And finally, environmental considerations. This was covered just a little bit in the preceding session. Does the project need an air construction permit? If it's big enough, likely it does. It's also state dependent, very state dependent. Some states require you to do a lot more legwork than others do. Texas used to be one where you just basically call up and say, we're going to build, and they'd say, fine, do it. Now you need a good 6 to 9 months. You have public notification in both English and Spanish. You have to post at your location. It is just a long laundry list in Texas of what you need to do to get your construction permit. And like they said this morning, it could take 6 to 9 months to get this. The other issue, when you're building a new facility or retrofitting it, is secondary containment rules for bulk liquids. Do the spill SPCC rules, spill prevention control and countermeasure rules apply. Basically, if you've got 20 gallons of oils, and that's soybean oils, mineral oils, diesel fuel, anything 55 gallons and above on your property, on your site, then yes, these SPCC rules apply. You may need secondary containment. You likely need an SPCC plan. So just keep that on there for a consideration. And Jess, I have 2 minutes and 11 seconds for questions. Any questions out there? We've got a lot of experts out there, but go ahead. You will have areas that are 2G1. The question was the electrical classifications, 2G1, 2G2. Are we classified 2G1? You certainly can have areas that are 2G1. Your unloading area would be number one on my list. If you've got open belts up top, yeah, that's 2G1 for sure. Tunnels could be, it depends. It depends. In the feed mill, in the feed industry, we had 3 or 4 areas that, okay, until proven otherwise, these are 2G1. Good question. I put him to sleep, Jess.
I have a question for you. If you're building a new facility, how many exits should you plan for?
That is a timely question, Jess. I'm glad you asked it. The grain handling standards, GSH, as I call them, require you to have 2 exits on your galleries and 2 exits on tunnels. And then OSHA gets kind of squirrely and says, after that, it depends. But what's important for that question is that June 10th of this year, OSHA put out a letter to their compliance officers to target exits and exit routes, basically asking you the question, do you have enough exits, and then prove it to me. It's going to depend on your layout of your facility, the number of employees you have, where your equipment is. There's a lot of depends. But those are questions that now OSHA is saying, yes, we want you to ask those of your facilities. But to answer your question, if you're putting a new facility, there's obviously a minimum of 2. Anything larger than a very small elevator, though, is going to have more than that.
Okay.
At 2 seconds.
And one more. If I put up work platforms for machine access, won't I also have to put more machine guards on?
The question, did everybody hear the question?
Okay, I'm sorry, I'll read. If I put up work platforms for machine access, won't I also have to put more machine guards on?
The answer to that question is probably yes, and that's going to increase your cost. But, and the reason this is a good question is, there's alternatives to classical encased machine guards. You can put a barrier up. If you've got a work platform that you're addressing for a bag filter, and on the other side, it's 10 foot up, and you got a motor over there with a sprocket, you can put a steel mesh up that prevents the operator from getting to that. So a much simpler type of operation. You can also have light curtains if they're applicable to your situation, or electric eyes. So, there's a lot more involved. There's a lot more opportunities out there than just your classical machine guards. But the answer is yes, you likely are going to need to address that situation if, in fact, it's within 7 foot of a working platform.
All right. If there aren't any other questions, thank you, Paul.